worthless circuit and we just give it to our local congressman because it's worthless as they are. So 0, 0. The good news is though, guys, that when we put 0, 0 through the gate, 0 becomes a 1, 0 becomes a 1. So indeed, we finally get a 1 out of it.
You would want to give that to the congressman, because then they put 2 congressmen and say they got something good.
Right, and then they'd overspend on it anyway, and you know, it's just a big cluster F, so we don't want that. Okay. What about circuit 2, guys? Let's see if circuit 2 does the exact same behavior, okay? So, if I throw a 1, 1 through this gate, 1 or 1 is a 1, I negate a 1, it becomes a 0. In fact, doesn't it look like that whenever I throw a 1, anything that has a 1 through the OR, it's a 1, and then it becomes a negation, which is a 0. So I know 1, 0 becomes a 0. I know that 0, 1 becomes a 0. And then finally, when I throw 0, 0 through there, 0 or 0 is a 0. When I negate that, that's a 1. Guys, I want you to notice that the input-output tables for circuit 1 and circuit 2 are exactly the same, which means they are logically equivalent. Okay, so you would say, yes, logically equivalent. Okay. Yes, sir.
So if you were to set up Boolean statements for the two.
Okay, so you would have not P and not Q, right?
Yeah, P, Q,
Okay. For circuit 1. For circuit 2, we would have not P or Q, correct?
No, P or Q, yeah, not P or Q.
Not P, because the not comes after, and then the or comes before.
So when you set this up, can you use the basic rules of inference?
Sure, or not the basic rules of inference, but the Boolean
So
laws.
you can't use the basic rules of inference.
Correct, because those are for argument forms,
Okay.
not for statement forms. Okay, so just one word difference, but unfortunately it does. Okay, guys, isn't it true that if you use De Morgan's law on either of these, it would give you the other one, right? So I could go ahead and use De Morgan's, and that would be not P and not Q, which is exactly the same statement. Okay, I don't care. Go ahead, Andre.
So, which one is the better one to use?
Ah, that's a good
Does
question.
it depend on the size of it?
Oh, it's all about size, isn't it? No matter what, it always comes down to size. I meant that in a perverse manner, by the way. just in case you didn't-
I got it.
Oh, okay, good. So, take a look at the next one, okay? Now, think about trying to make a simplified Boolean statement for that one, okay? That would be ugly, right, guys? And I like what you're going at, okay? The bigger the circuit, the more complex this animal's going to get, which means we have to use more brain power, okay? We can either bully it or we can finesse it, one of the two, right? We prefer to finesse it, but, you know, if it comes down to time versus brain power, a lot of times we pick time over that. So, I'm not going to say that one's better in any instance, depending upon what you're better at, maybe, okay? I don't know if that answers your question or not. Okay, good. Okay. So let's go ahead and finish this guy off, and then we can be done for today. So we have a P, we have a Q. I'm going to call the monster circuit C1, and I'm going to call the baby circuit C2. Okay. Clearly, we'd rather work with C2. Okay. So let's just devise an input-output table for this. So we have circuit 1. Let me give you guys a suggestion, okay? Because I don't know if these are true or not, but why don't we start with the easier circuit? Because that way, if we're running through the harder circuit and we get one that doesn't work, we haven't done all the hard work first, right, guys? Doesn't that make sense, guys? Always knock out the easy stuff, and then if you get a contradiction between the outputs, then you just be like, oh, okay, it's wrong. I don't have to do the harder stuff, okay? So if I do C2 first, okay, as long as P is a 1, the output's a 0, or the output's a 1 as well, okay? So I would get 1, 1 for the first two, okay? Now, the only time that this is going to be a 0 is if Q is a 1, because if this is 0 and this is 1, I would get 0, 0 through this. So I think the only one that would give me a 0 is going to be 0, 1, okay? So, does that make sense for circuit two, guys? Go ahead, sir.
Does the symbol, the little dot right after the dot, mean anything?
Oh, no, I copied it from somewhere, maybe not legally, but, the dot just means, just ignore the dot there, okay? I've seen it written with and without the dot, okay? I just don't do it because it's a pain in the ass. Alright, guys, let's see if this circuit's true, okay? In fact, might it not be easier just to go one by one on these? What's the only time that this first component is true?
When both are true.
1, 1, right?
Mm-hmm.
Oh, any other time, forget it. Okay, so 1, 1 gives us a 1. Okay. What is the only time that the second component is true? When the first one's a 1 and the second one is a
0.
0. Doesn't that make sense, guys? So 1, 0 gives us a 1. And then finally, what's the only time that this last component is going to be true?
Both are zeros.
If they're both zeros, right? And then that by default means 0. The difference is, remember the method that we used before, where we just worked from left to right and we just built the circuit? Like if I gave you this table, all right? If C1 is the result of the method I showed you, C2 is the result of you trying to brain power, if you would, okay? So that's the difference between those two, okay? And obviously, we would say yes, they are logically equivalent because the tables are the same. Okay, so, yes, logically equivalent. Okay. So, any questions I can answer for you guys about the Boolean logic stuff? Okay? Sir, please.
We're saying yes, logically equivalent, we use something like valid by input output.
Oh, yeah, sure. I think the question, I guess it just matters about what the question asks. It says determine if they are, so yeah, you could say valid by input output table. That'd be perfectly fine, as long as you answer the question, give me some substitute answer. Okay? Other questions, guys, I can answer. Okay,
So
go ahead, sir.
if you were to write it on a Boolean algebra type, we'll like P, the circuit one, P and Q, then
Oh,
P
boy.
and not Q, and not P, not Q, and you have to add all of them to the odd sign.
Correct, or between all of
All
those.
three.
And then have fun with that. 'Cause That's
Okay.
just ugly. Okay. Other questions, guys? Okay, so for next Wednesday, I'm going to ask that you guys complete assignment 2. Okay. You can do anything with Boolean logic circuits on assignment 2. So maybe over the weekend work on those, and then the rest of the stuff concerning the number bases in the 8-bit edition, we're going to do that on Monday next week. But assignment number 2, that's going to be due on, I think we said what, the 14th? Okay. And then also, remember those last 2 questions with the logical, with the argument forms? Those will also be due. Okay, so assignment 1. I think it was problem number 11.
Yeah.
Was that it? Okay, so 11A and 11B. Okay? Alright, I do have your guys assigned, oh no I don't, I got the first one, so that's fine. I'll have those graded for you guys by Monday, but remember I post everything in Blackboard, so if you want to know your grade, I'll also post the solutions for you guys as well, so you can look through those, okay? Alright, so I will see you guys Monday, have a splendid rest of the week.